All right, so welcome to part 2 of our discussion with exponents. Today we're just going to focus on using the product rule and the power rule and a few more examples of each one. So remember, the product rule says if I have a to the m plus a to the n, I go ahead, keep my base, and add my exponents. All right. If I go ahead and take some base to a power and then put it in parentheses, take it to another power, I'm going to go ahead and multiply my exponents. Let's look at a few examples strictly from the product rule. So we'll be using the first rule for these. All right. If I have x squared times x to the 9, all right, this is a straight definition of the product rule, which means I'm going to keep my base x and I'm going to add my exponents, which would give me x to the 11th power. All right. Another example here, we've got 5b to the 3rd times b to the 5th. All right. Now remember, we have an imaginary 1 in front of anything that does not have a coefficient. So what we're really dealing with here is multiplying our numbers, so 5 times 1. And those are being multiplied by my exponents, b to the 3rd times b to the 5th. So for the numbers, I'm just going to go ahead and multiply. So 5 times 1 is 5. My exponents, I need to go ahead and add my exponents. So 3 plus 5 is 8, and I'm going to get b to the 8. All right. You don't necessarily have to rewrite it like I did, but the biggest problem with these rules, especially the power rule, usually the mistakes come from the number part and not from the letters or variables. All right. One more example with the product rule. So I have 6y to the 7th. I'm going to multiply that by 5y to the 8. So I need to multiply my numbers and then use my product rule for my variables. All right. So I have 6 times 5, and then I have y to the 7th times y to the 8. So 6 times 5 is 30. No problems with that. And I need to go ahead and add my exponents. So my y to the 7 and my 8 is going to give me 15. All right. So I have y to the 15. All right. So that's a quick overview of the product rule, but it seems kind of silly, but guess what just happened? Congratulations, you just multiplied monomials. You have started the very beginning of multiplying polynomials. In this case, they were all monomials, so congratulations, we are actually now moved into multiplication of monomials. All right, now let's go ahead and look at the power rule. Remember, the power rule states that I'm going to have some stuff taken to another power. So our first one here, we're going to do a to the 3rd. Oh, I don't want to do that. A to the 3rd, and we're going to take that to the 3rd power. You can think of this in one or two ways. I could think of it just strictly as the power rule, and the power rule says I go ahead and take my exponents and I multiply them, and that gives me a to the 9. Okay. If for some reason you forget the power rule, we can also use our rules for exponents that say this outside exponent tells me to multiply everything in here that many times. So I could also rewrite the power rule like this, and now it became the product rule. So this is why I say that the product rule is the most important to remember, because you can always revert back to that. Not that you always want to, but now we created the product rule. And I can go ahead now and add all my exponents and keep my base. So 3 plus 3 is 6, 6 plus 3 is 9, and I end up with the exact same answer no matter which way I go ahead and approach it. And you could do any of these either way, doesn't matter. I'm going to go ahead and look at another one. Now I'm going to strictly just do the power rule. Okay, but remember, you can revert back to the product rule at any time. And I have two things now inside of my parentheses. What I want to think of is that each of these items has an exponent of 1. We talked about that in the last video, all right? Which means I'm going ahead and taking my A and multiplying my exponents, which in this case is 1 times 2. I'm also taking my B and multiplying it by 1 times 2. In a way, you could kind of think of it as an exponent distribution, where this exponent out here is going to apply to everything inside. And in that case, we get A to the 1 times 2, or 2, and B to the 1 times 2, which is 2, and we are done. Let's look at another one. I like A and B today. A and B is popular in my world today. Right? So now we have something other than 1. We clearly see that each of these has an exponent, and we're going to take that to the 3rd power. All right? And all we got to do is multiply. So A to the 3 times 3. And B to the 7 times 3. You're going to get some bigger numbers from here. That's okay. So A to the 3 times 3 is A to the 9th. And B to the 7 times 3 is 21. And just leave it just like that. You're done. All right. One last power rule for the day. All right. And I'm going to include a number with this one. All right. Now, when I look at the number, that number also has an exponent. Please don't try to multiply that number by the exponent. That's not going to work. We want to take our 5 and multiply the exponents. So we're not multiplying that 5 times the outside 2. We're multiplying the exponents. Then we also have A squared, and then multiply it by that outside exponent, 2. Okay. So 5 times, and its exponent is 1 times 2, so I have 5 squared. And A to the 2 times 2, which is 4. Now I can do this operation. 5 squared is 5 times 5, which is 25. A to the 4th. Right? To help you go see this just a little bit better, I'm going to go ahead and use the product rule instead. So instead of using the power rule, I'm going to go ahead and take my 5a squared, and it's squared, so I got to multiply it by itself 2 times. Now it's a lot easier for me to see that 25 coming from the 5 squared. So this is 5 times 5 times a squared times a squared. And using my product rule here, 5 times 5 is 25. A to the 2 plus 2 is a to the 4. And I have a match of what I got here. Okay? So that ends today's discussion. Go ahead and try the problems, and I'll see you in the next video.